So there are two types of lenses, converging lenses, which are kind of like convex, and then we have diverging lenses, which are concave in shape. All a lens is just something that takes light from an object and makes an image out of it that can be magnified, right? Upside down, right side up, kind of like a mirror, but it's not like reflecting any light, it's refracting light. So we're gonna look at how do lenses work, and I made them so large because I want to show you guys how light actually passes through a lens and how they use refraction in order to make images. So starting with a convex lens or a converging lens, this is really how this works. If you have light coming in into the lens, right? Let's just have it coming in straight. We know it's going to pass the glass, which is a different medium, right? Glass slows down light because it's, light's the opposite of sound. Sound waves travel the fastest in solid because they need like a medium to pass through, and with the molecules so packly tight, it'll go a lot faster. But light is an electromagnetic wave, and it doesn't need a medium. So glass, all those molecules just slow it down. So if you think about Snell's law, right, that tells us how light bends, there's going to be a normal line, and I just erased that part of the mirror. There's going to be a normal line at that point in the mirror where the light passes, right? And it could be light anywhere, right? Like light here, the normal line is different. The normal line is just the line perpendicular to the lens at that specific point. A lens is made of circles, right? Like this is, like one side of it is like a spherical shape, the other side is a spherical shape. So the normal line will always kind of point towards the radius of that circle, right? If you imagine the radius, it's always normal to the circle. And by Snell's law, we know that light will bend towards the normal when passing through a slower medium, right? Because if you think about, right, N2 over N1 is going to equal sine theta 1 over sine theta 2, right? N2, the index of refraction for glass, is larger than air because it slows down more. So it's larger, so the incident angle is going to be large, or the sine of the incident angle is going to be larger than the sine of the refracted angle. And sine, right, it increases when the theta itself increases. So sine theta 2 is going to be smaller, or theta 2 is going to be smaller. In general, it's going to bend toward the normal. And that's kind of the key idea here, right? Take a look. If I draw this in, right, this is a converging lens because the normal line always kind of points in a direction that focuses the light, right? Because light will always bend towards the normal line. So that light will naturally, right, if it's hitting up at the top, it'll naturally bend down. If it's light's hitting from the bottom, it'll naturally bend up. It'll bend towards the normal. This lens is just using refraction. Now, from here, right, like you usually draw, like you usually draw it just straight down from here, right? But in reality, there's still a normal line, like right here, right? You're still exiting into a different medium. And now you're going from high index to low index. So this angle of incidence now will be smaller than the angle of refraction entering into the air. Well, now you can see things have kind of flipped. The normal line used to point down up here. Now it's kind of pointing up. So if you're bending away from it, it's going to continue like going even more down like that. You can see this angle is larger than that angle. Same thing here. If I draw in my normal line, it will kind of look like this. It's going to get a bigger angle. Now in our lens diagrams, we don't really account for this, but the optics equation for lenses, it's almost like the same thing as the mirror equation. It's derived to account for this, right? So even though in your lens diagram you don't have to really worry about it, the math still would check out. And yeah, you would see that the light, right, when you hit from the parallel, it would always focus at a point, and we call this point the focus, the focal point. So, this is a converging lens, right? It focuses any light coming straight into the lens. Now, if you think about a diverging lens, it works really, it has the same principles, everything's just reversed. So, if you have light coming in like so, right, now the normal line is kind of pointing more up. So if the light will bend towards the normal, it'll bend up because the normal's pointing up, right? Same thing here. Right now the normal is kind of more down. It will bend towards the normal, which is pointed down. And then when it's exiting, right, now the normal line's kind of pointed down, it's going to bend away, so it's going to keep bending up because the normal is pointing down, it's trying to bend up. So same principles here, even though my marker is kind of dying, same exact principles. And this light will seem to converge at a focal point that isn't, like light really isn't like hitting this focus. But we call it kind of like a virtual focus, I guess. In our equation, we would represent this with a negative number to kind of signify that it isn't really a focus, and then the math kind of checks out. So yeah, that's kind of lenses, just like an intro to lenses and how they work, because you know, it's just refraction, right? Mirrors use reflection, lenses use refraction. So there you go. Hopefully this video makes sense. I'll make more if you need more videos on like the mirror equation or the lens equation. Same as the mirror equation. I can happily do that. Thank you for watching. Bye.